In this video, I'm going to go over solving quadratic equations with a difference of perfect squares. Now, first of all, what is a perfect square? Simply put, it's when you take the square root of a number and you get a nice whole number. Because most of the time when you're taking square roots of numbers, you're going to get some monstrosity biblical decimal that goes on forever, right? Except when you take the square root of 1 or 4 or 9 or 16, 25, 36. And if you want to remember, which of those numbers are perfect squares, you simply just take the whole numbers and square them. Just basically counting. 1 squared, 2 squared, 3 squared, 4 squared, all the way down the line. 10 squared, 11 squared, 12 squared, 13 squared. And it's nice to memorize these first 13, obviously, but if you don't, you can always grab your calculator and type in 13 squared, 13 times 13, and get 169. And it's important to note that exponents are a little different. It's just any even numbered exponent is a perfect square because it's x times x, and then it's x squared times x squared. Gets you x to the fourth, because when you multiply variables together, you add the exponents. So it's actually 2 plus 2 and 4. Instead of 2 times 2 gives you 4. So in this case, it would be x cubed squared. Okay, x to the fourth squared is x to the eighth. X to the fifth squared. Because when you take the power of an exponent, when you raise an exponent to another power, you multiply those exponents together. So 5 times 2 is 10. And so on all the way down the line. So that's what a perfect square is, something that comes out nice and neat. Now, when we get a quadratic equation like this, there's the standard form, the ax squared plus bx plus c equals 0. That's the standard form, right? Well, there's no b. B equals 0 in this case. So there is a b, it's just b equals 0. So there is no bx, it's just ax squared plus c, where c and ax squared are perfect squares. I'm like, wait a minute, both of them have to be perfect squares? Yes. The first number and the second number have to be perfect squares, and it has to be subtraction. It has to be. It's very specific circumstances we're talking about here. So what do you do when you have those specific circumstances? Well, that's what this whole video is about. We factor it. How do we do that? Well, we look at the second number, the c in this case, and we see what it is. C equals 9 in this case. Okay, well, 9 is a perfect square. What is the square root of 9? It's 3, right? Okay, we have that. So now that we have the square root of c, we take that and we can factor this out. Now, x is no longer x squared, it's just x, right? That's the square root of ax squared, right? So we're kind of doing the same thing there, but you'll see that's the similarity. It's a similarity between factoring, normal factoring and difference of perfect squares factoring. It's kind of the same thing. But here's where things take a turn. So we have 3, right? Both of these are going to be 3. Now, the signs are what's tricky. People got to remember. One of them is going to be positive and the other one's going to be negative. Does it matter which one's which? No. Left or right doesn't matter. But one of them has to be positive and one of them has to be negative. Why? Well, what we're doing when we're factoring is we're doing the reverse of the distributive property, right? Remember the distributive property when you when you kind of take a number and you distribute it to both of the numbers and another number, right? Let's just do it real quick. Also called foiling when you have two binomials. So x times x, x squared, right? X times -3 minus 3x, okay. 3 times x, okay, that's positive 3x. 3 times -3 is -9. Well, combine like terms, right? We have two terms that are the same here. They got 1x each. -3 plus 3 is 0. So we're left with x squared minus 9, because those kind of just canceled out. And that's exactly what we started with. So we know that we did it right. But that's the idea behind it. We figure out what the square root of c is, and then we just change the signs. It's probably the easiest factoring you're going to do, but it's under such specific circumstances. You got to watch out. You got to make sure that you've got a difference of perfect squares. Both of them are perfect squares, and they're being subtracted. They're being added, doesn't work. If one of them is not a perfect square, it doesn't work. If b doesn't equal 0, then it's not a difference of perfect squares. All right. So now that we've factored it and we checked it, now we solve it, right? Now we get to the solving part of this, where we need to figure out the values of x that make the statement true. Now, if this part is 0, and that's anything, whatever this is, multiplied by that 0 is going to equal 0. And same thing here. If this equals 0, then, and if this could be anything, then the whole thing is 0, because anything multiplied by 0 is 0. So we separate them out, right? To figure out what values we get that could make this 0 or that 0 to make the whole thing 0. It's that easy. Subtract 3 from both sides, add 3 to both sides. The answers are -3 and +3. Now, check that answer. Put -3 in for x, right? So it's -3 squared minus 9 equals 0, right? -3 squared is 9. 9 minus 9 does equal 0, so that's good. +3, same thing. Just checking our answers, making sure we got it right. It's not so bad, is it? One more example before I wrap up this video. What is the square root of 169? 13, right? So separate that into two binomials, x minus 13 and x plus 13, right? Equals 0. Separate them out. Get two different equations. Solve for x. One of them we get -13. One of them we get +13. Easy, right? Now, let me show you why this works. What if I didn't know all this stuff about factoring? What if all I did was try and solve it by, the old algebraic, run-of-the-mill methods, just trying to isolate x, right? X squared minus 169 equals 0. Well, I would move the 169 over, right? X squared equals 169. Now what do? if you were thinking square root of both sides, because we haven't quite isolated the x yet, but there's still a 2 attached to it. We want just the letter x over here, a variable. So what do we do to get rid of an exponent? We do the opposite of the exponent, and we take the root of that exponent, in this case 2, so it's just square root. And if we do that to one side of the equation, we got to do it to the other side, right? And there's a rule when you do this. When you take the square root of both sides, your answer is going to be positive and negative, because you could have a negative number in there that multiplies by itself to get a positive number. So it's x equals positive negative 13. Wait a minute.